It's a sad day. It's a sad day. My dad just sent me an article and said that Brugger's just filed for Chapter 11 bankruptcy. What am I going to do? What will I do without a hot cup of Brugger's coffee? Tim Hortons? Did you just say Tim Hortons? No. Brugger's. Stay in business, Brugger's. You should have hired me as a sponsor. I'd make you millions. Okay, let's get started. Ooh, day 3. What color we got here, kids? What color? Oh, it's my favorite. Mr. Key. Coming to show you. All right, kiddies, here we go. Let me get my highlighter out and get a couple things going. All right, for those of you in class that are watching because, whoa, I went way too fast. Sorry about that. Speed up. Learn to go quicker. For those of you that weren't in class because you had to go to those important things like the Model UN, I hope you had a good time. Just kidding. Hope you kicked some butt. If you didn't come back with the medal, maybe you shouldn't come back. I know you guys did. You guys are awesome. All right, wait. Somebody else missed my class. What was that other thing for? Oh, yeah, that play. I'm a little jealous. I didn't get to go see that play. Sounds kind of cool. All right, kids, look what we got here. On the same set of axes, notice missing axes. You got to do a little bit of work. Got to do a little bit of thinking. Use your brain for more than growing hair. See, this is what happens when you use your brain for growing hair. It just falls out. See, if you use your brain for other stuff. What am I talking about? I don't even know. Let's get going. On the same set of axes, we're going to graph. Oh, let me grab some color first. Oh, well, we're going to graph this equation. And we're going to graph this equation. 2 equations. Oh, my God. It's going to be so difficult. Oh, wait. Over the interval, they're actually restricting your domain. They're actually going to restrict your domain. You got to use a certain domain here. So we're going to graph those two things over this interval using the graphs from the following satisfy. Oh, we'll come back to this. We'll come back to that. So let me get a couple colors. Let's say in red, we'll do y equals sine 1/2 x. I think you notice on this one, there's no horizontal translation or phase shift. There's no vertical translation. It's just strictly a simple curve. Now, it's not so simple because we got that half. And we hate fractions, don't we, kids? Oh, we just hate that. That's the F word we're not allowed to use in class. No, wait. That is the F word you're allowed to use in class. Fractions. They're so much fun. All right, -3 sine 2x. Now, if you're at home partying with me on a Saturday and you don't have a cup of Dunkin', don't drink it. Oh, I just say don't watch it, the competition. Brugger's coffee. That's probably a good thing. You're too young for coffee. Besides, you might get overstimulated with all this great math and coffee, and we wouldn't want to be responsible for that. Who's we? I don't know who we is. Maybe there's somebody down here with me in my basement. All right, so we're going to go through. Remember, notice I don't give you all this stuff. A, amplitude. Oh, that's just 1. That's pretty simple. B, this is going to be the hard part, is my frequency is 1/2. Recall what that means. Say it in your head or say it out loud. Nobody's knowing that you're talking to yourself. I'm talking to myself. Actually, I'm talking to you, but there's nobody around, so I'm really kind of talking to myself. Gosh. Coffee. I'm going to finish this coffee, and I don't know what I'm going to do. All right, remember, that means we're going to finish 1/2 of a sine curve in 2 pi. 1/2 of a sine curve in 2 pi. All right, so now we're going to look at period. How long, and remember, period stands for how long will it take to complete an entire curve of pi. So if I can finish half a curve in 2 pi, wouldn't it make sense it would take 4 pi to do the entire period? But we'll do the math. Remember, it's 2 pi over b, which is 2 pi over 1/2. Remember, multiplying by or dividing by a fraction is the same as multiplying by the reciprocal, 2 over 1. So yes, there it is, 4 pi in all of its glory. Yay! And to make our life easier, we're going to come up with a scale. And our scale is going to be 4 pi divided by 4, or just pi. Now, we can't just get ready to graph that. We have to actually do both work, and you'll see why in a minute. So in this case, A is 3. Remember, we do not worry about the negative. The negative is a reflection in the midline. B is 12, or 2. 2 full curve in 2 pi. Ooh. So period is equal to 2 pi over 2, or just pi. So it takes pi to finish a full sine curve. And my x scale is pi over 4. Now you'll notice we're missing axes. We're missing axes. I'm not giving them to you. You're going to have to think about where they go and where to put them. And you'll see how that works in a minute. But it looks right here like I want to go to the left, negative pi, and I want to go to the right, positive pi. So therefore, my y-axis actually does belong in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh man, I lost track. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Man, drawing straight lines with this, especially, I don't know, maybe you heard. All right, kids, that's your brain on coffee apparently. 1, 2, 3, 4, 5. Oh, this one's going. Oh, this one's no. Oh, there it goes. Oh, oh! I started to talk about how cool I was doing. Whew, lines are a pain on this tablet. There's probably an easier way. I just don't know it. All right. Hold on just a second. All right, here we go. Sorry, I was just checking something out. For you, it was no time. I was out for a couple of minutes checking something. I don't know what happened. No, I can't write. Oh, there it is. Hate when that happens. Okay, need a new computer, kids. All right, so let's see what we got here. I think I can actually draw straight lines. Let me try to draw. It's actually better than what I had before. It's not quite in the right place. Step it down. I'm just trying to look. Oh! That's like page down, page up. All right, so whatever. I'm not sure if I'm in worse shape or better shape. All right, well, that's in better shape, I guess. So anyway, so what I'm going to do is come by and grab some tick marks. Now, I can do one. These are my X scale marks. Now, if I use this one, I would go pi, 2 pi, 3 pi, 4 pi. So we counted by pi's on this one. But then I would, on this one, I need to count by pi over 4s. And, well, I don't, and not to mention, didn't this thing say we just want to go from negative pi to pi? So that would mean I'd go, from negative pi to pi. It means I'd only be graphing between these two things. And I really don't want to do that. I can't tell you how much this line is drawing. It's driving me crazy. I'm going to try drawing another line. See if it'll let me do it again. I'm going to try to draw a better line. Draw line. I think it was right here. It doesn't matter too much. Oh, that's much better. I'm going to use that tool. Okay. All right. Ooh, that's much better. Although, maybe I should get rid of this one. Maybe I could do a better one than that. If I can just get on there and... No. Oh. God, dog, doob, dumb, boom, dung, dung. I forgot to select the line. You guys are at least learning how to use OneNote today. By the way, OneNote is a cool note-taking app. If you've got... Somehow, I'm going too high. I'm going to get this on the next one. It's so much better. I should have paused this. Sorry about that. Oh my gosh, where did that come from? Maybe I should just erase this. Maybe I'll erase this in the things. Maybe I won't. Maybe I'll show you how frustrating this is. All right, OneNote, by the way, is a really cool app. You might want to fast forward until you start seeing me work again. Whatever. All right, I'm going to stop there. It's mostly on. It's mostly on. Okay. So what we're going to do then is, the rule then is, not the rule, but what you want to do is you want to use the smaller scale to put on your graph. So we're going to use pi over 4, pi over 2, that's 2 pi over 4, 3 pi over 4, and pi. Now notice I end at pi, which is kind of where they wanted me to end anyway. They want me to go from negative pi to positive pi, so this will be negative pi over 4, negative pi over 2, and negative 3 pi over 4. Okay, so there's my scale on my x-axis. I have to get up to 3, so my scale on my y-axis is going to have to be every box is 1. So I'll just make that positive 2 and negative 2. All right, well, we're sort of ready to graph. Now what you want to do is you want to graph the one that you use the scale for first, and you'll see why as we go through this. So you'll notice that there is no horizontal or vertical phase shift, so we'll start at 0, and the sine curve's features are that every other one of these tick marks, every one of these scale marks will be a 0. Now, in between, because this is a negative 3 up here, we're going to go down 3. In between these, we're going to go down 3 first. And then between these two, we're going to go up 3. So much easier to draw a curve than it is a straight line. I don't even know why. And then we'll go this direction as well, because we have to go from negative 2 pi, or negative pi to 2 pi, or negative pi to pi. I guess in my head I was saying, oh, that's a total of 2 pi. No, I wasn't. I was just talking weird. All right, so now we've done a green one. Let me switch back to red. Red will be a little bit more difficult. Red's a little bit more difficult. And let me give myself a little bit of room. You probably have some space somewhere, but I don't want to take it off this. So I want to show you guys just a quick sketch. What we're going to do is we're going to make a quick and dirty sketch of what this would look like. Pi, 2 pi, 3 pi, 4 pi. If I had to quick and dirty sketch this thing, start at 0, end at 0, 0 in the middle. This one has an amplitude of positive 1, or just it's got a 1, and we're going up positively. So at pi it would be 1, at 2 pi it would be 0, at 3 pi it would be negative 1, and at 4 pi it would be pi. Now here's the kicker, here's the key. I'm only graphing on this graph to pi. So on this graph, I have to actually stop here. I don't even get to see any of this because that's all off in this direction here, and we're not going that far. So it ends at pi. Well, at pi, the red curve is up at 1. So I'm going to come back to my graph, and I'm going to say, okay, at 1, or excuse me, at pi, the red curve is 1. And if I went off in the other direction, of course, negative pi would be negative 1. So yeah, here's that curve. Now this is going to be hard, maybe. Not bad. Not bad. All right. Now that kind of makes sense. Remember, it's at 1, at pi, it's at the top. And then this would eventually come down at 2 pi, all the way down to 3 pi, and so on and so forth. So yeah, that's the tricky part. One of the graphs is probably going to look normal, and the other graph is going to either look really stretched out or really compact. All right, so that's that. We got to go answer the question, though, and the question is, it doesn't ask for the specific exercise. It says, find the number of x's. The number of x's that satisfy an equation where they are equal. And you all remember that equations are equal wherever they intersect each other. So we're going to take out the cool blue pen. We're going to say, okay, they intersect each other here, 1, 2. They intersect each other here, 3, 4, and 5. So the answer to this question is they intersect each other 5 times. Now, in the future, algebraically, we're going to find out what these value is, because to find out that value right there graphically is very difficult. Now, this one's easy. It's just 0. But all the rest of them that are circled are often some, probably an irrational location where it will be very difficult to do graphically. Now, you can use your calculator to get an estimation, but we're going to use our algebra skills next week to figure that out. All right, let's get going again. So let me get red out. So we're going to graph y equals 2 sine x. And I'll do all that work over here. A equals 2, B equals... Now, at this point, you probably should be pausing it because this is what I did in class. I, took a mental pause. I made you guys work in class and then come back and see if you get these right, because these things you should have down by Pat by now, or down by Bob by now, or Joe. Not even sure who Pat is. B is 1, so you should have paused it. Now you should be back. Period is 2 pi. Oh, you didn't pause it? You're just watching the performing monkey? The performing monkey! I'm not a performing monkey for you. Pause it and do it on your own. Pause, period. Once you have them done for all three, or, both equations, come back. 2 pi over 4 pi over 2. Well, I hope you did. Thank you for doing that. I'm going to guess you did because I got awesome kids. So I'm going to guess you actually did pause it. Especially those of you that went to the Model UN. You guys are the model citizens of America, and you should have done it. Well, maybe not you, Neary. Just kidding, Neary. You're awesome. By the way, I should take a picture of Neary's test. You all should aspire to take tests like her. Although some of the other guys have I actually have guys this year that have amazingly neat tests. So cool. And I'd say that in all of my humbleness because you can see how neat I am. Hopefully you guys are still paused this and you're still coming back from a pause. A is 1, B is 2, C is 2 pi over 2, which is just pi. And then period, not C. This is period. What am I doing? Don't watch me. The performing monkey has messed up. Period is equal to that. And x scale is equal to pi over 4. So these are our two scales. And we are going to pick the smaller one. This is the smaller one. So we're going to end up graphing the green one first. Now, let me put my axes right here in the middle, and we'll go back over here, we'll do that, and then we'll go through and graph it, and then we're like, oh my gosh, I should have probably read. I don't want my axes in the middle. It says to graph from 0 to 2 pi. Ergo, no negatives. So, mistake. Besides, I didn't get to use my cool draw tool. So, we're going to... Really? I didn't like that. Oh, this is pretty good. That's pretty good, kids. Oh my goodness, yay! I'm guessing. I think it's about here. Oh, yes, that's so much nicer. Okay, there we go. All right, so now I can go back to drawing. So we're going to use this scale. We're going to... Wait, did I just put my axes in the middle? Monkey see, monkey do. Gotcha. Come on, kids. You got to be able to use your brain. Actually, that was just a complete brain fart on my part. I didn't mean to do it, but it was a great learning tip. Oh, yeah. Delete. Oh my gosh. Not feeling the love here, kids. Oh, much nicer. Okay. So there's my axes. Now we're gonna go by this scale. And we gotta get to 2 pi. So pi over 4, pi over 2, 3 pi over 4. This would be pi. 5 pi over 4, 6 pi over 4, 7 5 pi over 4. And 2 pi. Okay, so we got there. I just wanted to make sure before I hand wrote all this out that I was actually going to get there. I already knew, by the way. I was just showing you what my brain would do and what I would do if I was you. I don't know why I whispered. I whispered like you aren't actually listening to me. So that's a little weird. 3 pi over 2. But you all know I'm a little weird. We're doing the green scale first. So... let's see, we got to get up as high as 2. That's it. So 1 and 2. The more stretched out you can make it, the better. -1 and -2. So green curve, start at 0. And every other one of these is a goose egg. In between, we'll go up and down. Now, my amplitude here is 1. It's positive, so we're going to go to up 1 first. And then down 1. And up 1. And down 1. Look, if you don't make fun out of math by pretending you're on a roller coaster, going wee or ah, usually I'm the one screaming like a baby. You ever seen those YouTube tutors with a 40-year-old man screaming like a baby? That's me. Let me draw a quick sketch here. 1, 2, 3, 4. Pi over 2. Pi. 3 pi over 2. 2 pi. That's what this one, that's the scale that this one would do. Start at 0, end at 0, 0 in the middle. And this one's going up to 2 first, then down to 0, and back to 2. So where are the zeros of the red curve? The zeros of the red curves are at pi and 2 pi. Oh, and we also have here. And in between the red, now you got to go in between the red is pi over 2, and we're going to be up at 2. And in between these two, or at 3 pi over 2, you're going to be at negative 2. So make your life easy by drawing that quick sketch off to the side. I know it's like twice as much work. Not really twice as much, but it's just a little bit more work. Oh, wait a second. Look at that. I put this over here at 7 pi over 4. This should be here. So now I got to start over because it was ugly anyway. Or to be more politically correct, it was not aesthetically pleasing to me. I don't even know if that's politically correct. It still means ugly. Okay, that's not bad. Still got to ask the question. The question is, find one value where the, let's see, sine of 2x, the red curve is bigger than the green curve, or greater than. Greater than on a graph means above. So we're trying to find the area for which the red curve is above, and I got to pick a value. So this is where the red curve is above, all the way up to here. So you can pick any value in this range. Now you can't pick 0 there and there because they're equal, and notice there's no equal sign. So I could pick a value like pi over 2. I could pick a value like 3 pi over 4. I could pick a value like pi over 4. I could pick a value like 11 pi over 83. I don't know where that is, but it's probably in there somewhere. It's less than pi. So anyway, there we go. Still hot. All right. So I'm going off to do number 4 now, kids. Number 4. Not 3, but 4. Decided not to do them all. I'm going to have you do them. We're going to go over them in class. I want you to try these on your own. All right. Let's see what we got here. Remember, all of this stuff can be found on the web. Let's see. Let me get back to my colors. So, y equals... Now, this one is a much more difficult problem. We've got a reflection. We've got a high amplitude. That's not necessarily what makes it difficult. What makes it difficult is we also have this horizontal translation or phase shift. And you should know that we're going to go to the right pi over 2. So we got a lot of work to do. We got more work to do on this one. We got a equals 3, b equals 1. My period is 2 pi over 1, which is just 2 pi. My x scale, hopefully you already did this, is pi over 2. My c value is... right there, remember, it's opposite, so it's pi over 2. Remember, anytime we do a translation on the horizontal axes or on the x-axis, we're going back and forth, left to right, but backwards. So that's why it's positive 2. D value is right here. Now, I haven't really had to talk about this, but when I talk about C, I want to talk about D, because those go together. My D value is 0, so I'm already losing my voice. This gives me my starting point. My starting point is... remember, these two make my starting point. Pi over 2 goose egg. All right. So if you watch me do that one, that's fine. Now hit the pause button, and you guys do this one on your own. Well, that was the second curve. Okay, we'll do this one in green. So y equals 2 sine 2x plus 1. Okay, now we've got a vertical translation, so we're going up 1. So my a is 2, my b is 2, my period is 2 pi over 2, which is just pi, and my x scale is pi over 4. My C value, now C value, remember the C value is the value that's in parentheses with the x, because that really is my indicator, that's my visual indicator that we are going to have a translation left or right. This thing's sliding left or right. But I don't have anything in parentheses with the x, so my C value is actually 0, but my D value is 1. So that makes my starting point 0, 1. So notice, neither place we're starting at the origin, because on both of these equations we had some sort of translation, either horizontal or vertical. We're going to use this one's scale because it's pi over 4. And I want to go from negative pi over 2 to pi over 2. So that because I'm going the same amount left and right, that means my x-axis will be in the middle. I think this is about in the middle. In the middle. And then I got to go draw another one. This looks like it's in the middle. Good enough. Sorry. Tick marks. We're going to go by pi over 4s. Wait a second. So we're going to go pi over 4, pi over 2, 3 pi over 4, pi. That should be good. We'll go pi. What? I have to get to 2 pi? How? What? That's only pi. I got to get to 2 pi. Oh, yeah. Let's cut each of these in half then. And that'll be our scale then. So this will be pi over 4. So I can't stretch it out as much as I used to because I don't get to the domain that they want me to graph this over. So you have to be able to adjust, chillin'. And this would be pi now. And this would be 5 pi over 4, 6 pi over 4, but that's 3 pi over 2, and 7 pi over 4. And of course 8 pi over 4. So 1, 2, 3, 4, negative pi, 5, 6, 7, 8, negative 2 pi. Now, I'm going to try to make my graph look a little cleaner. We got a nice scale over here. If I need to, I'll come back over here. Of course, this is just negative pi. Well, here, how about this? Negative pi over 2 and negative 3 pi over 2. That's my quadrantal angles anyway, right? Like 90, my 180, 270, 360. All right, I need to get up as high as 3. I know this one's only going up to 2, but I need to get up as high as 3. Oh, wait a second. This one has a midline. Remember, we got to graph that midline. So my midline here, let's see if I can draw a dotted line. Let's see if this thing will let me draw a dotted line. Okay, well, so we're going to draw a dashed line along this axis. I'm going to do that in a different color. I don't know why I just picked my erasing tool. I have an eraser on the back of my pen now. So draw, let's do it in black. You'll notice I gave you very faint graphs on this, and the reason I did that was because I was hoping it'd be easier for you to put all these little helper lines. I know the other ones the other day were a little dark. And if you print these out at home, this will be blue. It'll be light blue like mine, so that'd be kind of nice. That's kind of what I was hoping for. Okay, let's go back to my green. All right, green, we're going to start at 0, 1. So I'm starting at 0, 1. Now, remember, now I'm use this one. The reason I'm doing graph is because this is the scale I use, pi over 4. So every other one of these is a 0. Holy mackerel, we got a lot going on. And in between, we're going to go up 2. So from the midline between these two, we're going up 2. And down 2. And up 2. And down 2. So your graph should look symmetrical with the midline. Should have curves, not straight lines. All right, now we got to go in the other direction. 0, 0, 0, 0. In between those, I'm going to go up and down, and up and down. Up and down 2 from the midline. Notice I'm going 2 down from the midline here, right? And when you graph your curve, it should look nice and smooth. Perfect. Not bad, actually. I know what you're thinking. You're thinking, Mr. Krause, you should have been an artiste. I know. All right, let's count this one. Pi over 2, pi, 3 pi over 2, 2 pi. Oh, okay. Well, that's where I'm going to end down over here anyway, so that's nice. Every other one is a 0, 0, 0, 0. In between, now notice we're going to go down first, down 3. So here we'll go down 3. Oh, wait a second. What's my starting point? Because, you know, I completely forgot, and this is one of the hard things. Sometimes you'll do this. There's my starting point. I have to start at pi over 2. That's weird. So my starting point, let me do my fancy blue pen. My starting point, I'm going to start at pi over 2. Now, every other point is a 0. 0, maybe I should draw a few this way. Let's see. This would be negative pi over 2. So if this is my starting point, I leapfrog, and I go to here is my next one, and my here would be my next one. So let me go onto my graph and do that. I'm going to do the first point in light blue. Pi over 2, 0. Right here. Now, you can't go every other point on this scale because this scale is different. You have to go up and use this. You got to say, oh, 3 pi over 2 would be my next 0. That's right here. And negative pi over 2 would be my next 0. Oh, I should be doing these in a different color. I can't get rid of that one. I'll just go over it. So let me draw these in black. You know, I told you I need a new computer, right? All right, so there, my next 0 would be here because based on this information, 3 pi over 2, and then negative pi over 2 would be my next one. And if I look at it, I'm going 1, 2, 3, 4. 1, 2, 3. So 1, 2, 3, 4. This would be my next one. And I go 1, 2. Oh, I can't do that. All right. Now, let me go back up to my graph here. I'm going down first. From here, I'm going to go down first, back up like that, and then up, and then down. So let's see if I can, let's see. In between, or at pi, I should go down 3. Let me get back to red now. So you know I'm graphing my red one. This should have been. So at pi, I'm going down 3. That means if I continue this, I should go up 3 over here. And then at here, I should be at 3. And in between these two, I should be down at negative 3. And then up at 3. Wow. That's beautiful, man. It's awesome. All right, so the question says, using the graph, find the number of values. It's not asking you to find the values. It's telling you the number of values. So we're going to grab our trusty, cool, light blue pen, and we're going to say, there's 1. There's where they hit. Ding, 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 ding. There's another place. And that's actually an answer. That actually I can find. That's negative pi over 2. Here's a weird one. Don't have any idea what this answer is. And here. 1, 2, 3, 4-bagger. And that's it, kids. And that's how you draw systems of equations, brought to you by the bankrupt Brugger's Coffee. Hit the like button. Hit the subscribe button. If you want to donate to the cause, those of you like in New York City or other teachers across the United States using my wonderful material, hit the donate button. That'd be great. I don't even know if I have a donate button, but there is something. I'm sure you can find a way to send me $1 or $2. It's okay. Maybe someday I'll be able to afford a new computer. Just kidding, kids. Bye. It's been fun. It's been real, but actually it's been real fun. 6 o'clock in the morning. Nothing better to do. Bye. I don't even know where my stop button is. Bye.